The air inside the passage was cold and still, carrying the mineral weight of limestone dust that had settled across 5 millennia. Dr. Lara Cassidy of Trinity College Dublin adjusted her headlamp, the beam cutting a narrow cone through the absolute darkness of the Newgrange inner chamber. The date was December 21st, winter solstice. Outside, a thin December dawn was breaking over the green hills of County Meath. But here, buried deep within the great mound, no natural light had penetrated since the previous solstice. The chamber waited, as it had waited every solstice morning for 5,200 years. Cassidy knelt on the cold stone floor beside the remains designated NG10. The bones had been excavated decades earlier from this exact spot, the deepest, most sacred recess of the most sophisticated passage tomb ever constructed in prehistoric Europe. The petrous bone, the densest part of the human skull, cradled the ancient DNA like a time capsule. She lifted it carefully, her gloved fingers steady despite the chill. The bone was 5,200 years old. Then it happened. A shaft of light, thin as a blade, entered through the roof box above the passage entrance. It traveled slowly, deliberately, along the 60-foot corridor, climbing over the carved spirals and lozenges that decorated the orthostats. For exactly 17 minutes, the winter solstice sun would illuminate the inner chamber. It was a feat of engineering so precise that modern architects still struggle to explain how Neolithic builders achieved it without metal tools, without the wheel. Centuries before the Great Pyramid of Giza rose from the Egyptian sands, before Stonehenge's great trilithons were raised on Salisbury Plain. And here, in the heart of Ireland, the oldest solar observatory on Earth was waking up. The bone she held in her gloved hand was beyond ancient, and when the sequence came back 6 months later, it would break everything historians had believed about ancient Ireland for 150 years. The story of what Cassidy and her team discovered in that chamber rewrites the entire opening chapter of Irish identity. Before that shaft of solstice light touched the carved stone, the academic consensus was settled. Neolithic Ireland, the textbook said, was an egalitarian farming society, peaceful, communal. No kings, no dynasties, no rigid social hierarchy. The great passage tombs like Newgrange were community projects, ceremonial centers where scattered farming clans gathered to honor their collective dead. The ancestors of the Irish were simple folk who tilled the soil and raised their families and buried their dead without much fuss over rank or bloodline. The DNA told a different story. It told a story so shocking that when the numbers first came back on Cassidy's screen at Trinity's ancient DNA laboratory, she checked them 3 separate times, convinced there had been a contamination error. The pairwise inbreeding coefficient for specimen NG10 registered at 0.25. That number is the exact statistical signature of a child born to 2 first-degree relatives. The man buried in the most sacred chamber of the most magnificent Neolithic monument in Ireland had parents who were brother and sister, or possibly parent and child. The DNA cannot distinguish between those 2 scenarios, but the biological reality is unambiguous. This was documented incest of a kind associated with exactly one type of society in the entire historical and anthropological record: dynastic god-king civilizations, pharaohs. The Inca, the pre-contact Hawaiian Ali'i, societies where the ruling bloodline was believed to be so sacred, so imbued with divine essence, that marrying outside the family was considered a dilution of celestial power. Cleopatra was the product of multiple generations of sibling marriage in the Ptolemaic dynasty. The Inca Sapa Inca married his full sister to preserve the solar bloodline, and here, in a green island on the western edge of Europe, 5 millennia before any historian imagined such complexity existed, someone was doing exactly the same thing. The Newgrange discovery did something else. It connected the man in the chamber to a network of other Neolithic burials across Ireland. Cassidy's team found distant kinship links between NG10 and individuals buried at Carrowmore in County Sligo, at Millen Bay in County Down, at the Polnabrone Dolmen in the stark limestone landscape of the Byrne in County Clare. These were not random village headmen. This was an interconnected dynastic elite spanning multiple ceremonial centers, a network of sacred bloodlines stretching across the entire island. The Neolithic Irish had built not just the most sophisticated megalithic structure on Earth at Newgrange, but an entire civilization of monumental architecture, astronomical precision, and rigidly enforced social hierarchy, and almost every trace of it had been invisible to archaeologists for a century. The stones were silent, the bones, it turned out, were not. To understand how we got from that sunlit chamber to the modern Irish person, the red-haired, fair-skinned, blue-eyed stereotype that populates postcards and pubs from Dublin to Boston, we need to go back even further. Before Newgrange, before the incest king, back to a woman whose face would shock anyone who imagines they know what the ancient Irish looked like. Her name in the scientific literature is the Ballynahatty Woman, and she lived and died approximately 300 years before the construction of Newgrange, around 3300 BCE. Her remains were discovered near the Giant's Ring, a massive henge monument just south of modern Belfast. When the team at Trinity College Dublin sequenced her genome, the first ancient Irish genome ever recovered, they were able to reconstruct her physical appearance with a high degree of confidence. The results were stunning. The Ballynahatty woman had brown eyes. She had black hair, dark and thick. Her skin was dark, likely olive-toned or darker, the kind of complexion you would associate today with a person from Sardinia or the Mediterranean basin, not the emerald fields of Ulster. And she was lactose intolerant. She could not digest milk as an adult. The mutation that allows adult lactase persistence, the single greatest dietary adaptation in European evolutionary history, had not yet reached Ireland. She was, in almost every visible respect, the opposite of the pale, blue-eyed, milk-drinking Irish phenotype that would define the island thousands of years later. Her ancestry tells the story of Europe's first farmers. The Ballynahatty woman's genome was predominantly early European farmer, a population that ultimately traced its origins to Anatolia, modern-day Turkey. Around 7000 BCE, these pioneering agriculturalists began an epic westward migration, carrying wheat and barley and domesticated sheep and goats across the Balkans, up the Danube River Valley, and eventually to the farthest Atlantic fringe of the continent. They were the people who built the first permanent settlements in Ireland, who cleared the ancient forests to plant crops, who raised the first great megalithic monuments. They were the architects of the Neolithic world, and genetically, they had almost nothing in common with the people who would come after them. If you walked through Ireland in 3500 BCE, the people you met would have looked more like modern Sardinians than modern Irish. Dark hair, dark eyes, olive skin. A population of Mediterranean farmers who had reached the absolute end of the European landmass and stopped, building their tombs and their kingdoms at the edge of the known world. They were there for a very long time, relatively speaking, but they were not there forever. Because around 2500 BCE, something massive happened. Something that would reshape the genetic destiny of Ireland and Britain so thoroughly that within a few centuries, the Y chromosomes of the native Neolithic men would be almost completely erased from the population. The Bronze Age Beaker culture was not a unified ethnic group in the way we might think of one today. It was a cultural complex, a package of technologies and burial practices and social structures that spread across Western and Central Europe starting around 2800 BCE. They made distinctive bell-shaped pottery beakers. They buried their dead in single graves with rich grave goods, copper daggers, gold ornaments, archery equipment. They were metalworkers, pastoralists, and by all archaeological evidence, they were aggressively expansionist. But the most important thing about the Beaker people is what they carried in their blood. The Beaker migration, when it reached Britain and Ireland around 2500 to 2000 BCE, brought with it a genetic signature that had never existed on the islands before. It was a signature ultimately traceable to the Pontic-Caspian steppe, the vast grasslands north of the Black Sea and the Caucasus Mountains. There, around 3300 BCE, the Yamnaya culture had emerged, nomadic pastoralists who domesticated the horse, invented the wheel, and developed a social structure built around patrilineal clans, warrior elites, and cattle wealth. They were the people who spoke Proto-Indo-European, the ancestral language from which Irish Gaelic, English, Hindi, Persian, and almost every language spoken between Dublin and Delhi ultimately descends. When the Yamnaya descended peoples began moving west, they did not just bring their language and their cattle and their bronze weapons. They brought their Y chromosomes. The landmark 2018 study, led by Inigo Olalde at Harvard Medical School, published in the journal Nature, sequenced 400 ancient European genomes and revealed the scale of what happened next. Within roughly 200 to 300 years of the Beaker culture's arrival in Britain and Ireland, approximately 90% of the pre-existing Neolithic Y chromosome DNA in Britain was replaced. 90%. Read that number again and let it settle. The male line of the people who built Newgrange, who raised Stonehenge, who had farmed these islands for 1,500 years, almost entirely supplanted. It is one of the most extreme male line population turnovers ever documented in prehistoric Europe. To put that in perspective, consider that the Norman conquest of England in 1066 is estimated to have replaced perhaps 5% of the English Y chromosome gene pool. The Viking invasions of the 9th and 10th centuries may be 10 to 15% in certain regions. The Beaker migration replaced 90% within a few centuries. The Neolithic men did not just lose political power, they biologically vanished from the paternal lineage of the islands. What did this mean in human terms? The archaeological evidence is sparse and ambiguous, but the DNA is not. The patterns suggest a massive influx of males carrying the R1b M269 Y chromosome haplogroup, specifically the R1b L21 subclade that would come to define the Irish paternal lineage. These men reproduced with local Neolithic women, whose mitochondrial DNA shows much greater continuity across the transition. The maternal line persisted. The paternal line was swept away. Whether this happened through conquest, through disease, through some form of social dominance that gave Yamnaya-descended males disproportionate reproductive success, or through a combination of all three, the genetic outcome is brutally clear. The result is a population that carries the Y chromosomes of the steppe and the mitochondrial DNA of Neolithic Europe. The modern Irishman is, in his deepest paternal ancestry, the descendant of Bronze Age pastoralist warriors who rode out of the east and claimed the farthest green island of the Atlantic as their own. And here is the thing. We know exactly what one of those Bronze Age arrivals looked like, because the same Trinity College team that sequenced the Ballynahatty Woman also sequenced 3 men from Rathlin Island, off the north coast of County Antrim, who lived around 2000 BCE. The contrast could not be more stark. Rathlin Man, specimen Rathlin 1, died approximately 1,300 years after the Ballynahatty Woman. That is not very long in evolutionary time. It is about 40 human generations, and yet Rathlin Man had blue eyes, he had light skin, and he carried the genetic mutation for adult lactase persistence. He could drink milk as an adult. He was, genetically, the template from which the modern Irish population would be cast. His autosomal ancestry was roughly 30% Yamnaya steppe, 40% Anatolian Neolithic farmer, 30% Western hunter-gatherer. The steppe component was new. It had not existed in Ireland before 2500 BCE, and it had completely transformed the physical appearance of the population. In the space of just over a millennium, the people of Ireland went from looking like the Ballynahatty Woman, dark-eyed, dark-haired, olive-skinned, lactose intolerant, to looking like Rathlin Man, blue-eyed, fair-skinned, capable of digesting milk into adulthood. The transformation was not gradual evolution through natural selection. It was population replacement through migration. The Neolithic Irish were not the direct ancestors of the modern Irish in any straightforward sense. They were a people who were genetically overwhelmed, replaced in the male line, absorbed in the female line, their physical type vanishing from the island except as a minority ancestral component, buried deep in the autosomal genome. This is the genetic skeleton beneath everything that comes after. The Bronze Age Beaker migration laid down the fundamental DNA of the Irish people, and every subsequent invasion, colonization, and cultural shift has been layered on top of that Bronze Age foundation. The Iron Age Celts, the Vikings, the Anglo-Normans, the English and Scottish planters, they all added their drops to the genetic ocean, but the ocean itself was already Beaker. And speaking of the Celts, here is where we need to confront one of the most persistent misunderstandings in popular history. The Celts are not a genetic group, they are a linguistic and cultural phenomenon. The Iron Age Celtic migration into Ireland, which occurred sometime in the first millennium BCE, left remarkably little genetic trace in the modern population. The languages came: Old Irish, the ancestor of modern Irish Gaelic and Scottish Gaelic and Manx, and the artistic styles came: the Latin metalwork, with its swirling curves and intricate knotwork, that we now think of as quintessentially Irish. But the people who brought those languages and those art styles were genetically almost identical to the Bronze Age Beaker population already living there. This is a crucial point. If you sequenced an Irish person from 1500 BCE and an Irish person from 500 BCE, their genomes would be very similar indeed. Both would be overwhelmingly Beaker-derived, with EEF and WHG minority components. What changed was the language they spoke, the gods they worshipped, the stories they told. The Iron Age Celts arrived as a cultural overlay, not a demographic replacement. The Celtic Irish identity, so deeply cherished and so fiercely defended over centuries of colonization and resistance, is a cultural and linguistic identity, not a separate genetic lineage. The genetic Irishman is a Bronze Age Beaker person who happens to speak a Celtic language. This is not to diminish Irish identity, far from it. It is to ground that identity in the actual deep history of the island, which is more complex and more fascinating than any simple origin myth. The Irish are not Celts in their blood. They are, in their blood, the product of a Bronze Age transformation so complete that it erased the paternal lineages of the Neolithic world and created something entirely new. The Celtic layer came later, and it gave that Bronze Age population its language and its mythology and its tribal names, but the DNA underneath is older and stranger. Let us trace what happened to that Bronze Age Beaker population as history unfolded. The tribal kingdoms of Iron Age Ireland, the Uí Néill, the Óganacht, the Dál Riata, the Olalde, were the political units that would shape the island's medieval history. And here is where modern DNA analysis has done something remarkable. It has validated the oral historical traditions that survived for over a millennium. In 2017, the Irish DNA Atlas Project, led by Dr. Edmund Gilbert at the Royal College of Surgeons in Ireland and Trinity College Dublin, published a study in Scientific Reports that analyzed the genomes of 194 modern Irish individuals with known regional ancestry, going back multiple generations. The team identified 10 distinct genetic clusters within the modern Irish population, and the boundaries of those clusters closely matched the territories of the medieval Gaelic kingdoms. People from the northwest of Ireland, the traditional territory of the Uí Néill dynasty, form a recognizable genetic cluster. People from Munster in the south, historically the domain of the Óganacht, form another. The northeast, the ancient kingdom of Olalde, shows its own distinctive genetic signature. The Dál Riata territory in the far northeast, which straddled the narrow sea between Antrim and the Scottish coast, shows connections to southwestern Scotland that reflect a millennia-old shared kingdom. Leinster in the east forms its own group. These genetic boundaries are subtle, but they are real, and they have persisted through the Viking invasions, the Norman conquest, the Tudor plantations, the Cromwellian settlement, the Great Famine, and the mass emigration of the 19th century. The Irish DNA is stubborn, it remembers. The next layer arrived with the long ships. In 841 CE, the Vikings established a winter camp at the mouth of the River Liffey, a settlement that would grow into the city of Dublin. From that base, Norse raiders and traders penetrated deep into the Irish interior along the river systems, establishing other coastal settlements at Wexford, Waterford, Cork, and Limerick. The Viking impact on Ireland was significant but geographically concentrated. The modern Irish population carries a modest Norse genetic signature, roughly 2 to 6% Y chromosome haplogroups R1A and I1 in eastern and coastal populations, the telltale markers of Scandinavian paternal ancestry. It is enough to leave a trace, not enough to transform the population. Dubliners carry slightly more Norse ancestry than people from the rural west, but the Beaker bedrock remains untouched. The Anglo-Normans arrived in 1169, landing at Bannow Bay in County Wexford, under the leadership of Richard de Clare, known to history as Strongbow. They came at the invitation of a deposed Irish king, Diarmait Mac Murchada of Leinster, who had sought Norman military assistance in his struggle to regain his throne. It was a catastrophic miscalculation. The Normans, once established, never left. They brought feudalism, stone castles, the English language, and a small but detectable genetic contribution to the Eastern Irish population. French and English Y chromosome lineages entered the island. But again, the impact was modest. The genetic bedrock of Ireland, laid down in the Bronze Age, absorbed these newcomers without cracking. The centuries that followed, the Tudor conquest, the flight of the Earls in 1607, the plantation of Ulster, the Cromwellian land confiscations of the 1650s, the penal laws, were political and demographic upheavals of immense brutality. But genetically, the Irish population remained remarkably continuous. The Protestant planter populations in Ulster, predominantly Scottish in origin, created a new genetic gradient in the northeast. The descendants of those planters, today's Ulster Scots, are genetically distinguishable from their Gaelic Irish neighbors, their ancestry tracing back to lowland Scotland rather than to the Bronze Age Beaker Irish. But even here, extensive intermarriage over 4 centuries has blurred the lines. The genetic map of modern Northern Ireland is a complex mosaic, not a simple binary. And then came the diaspora, the Great Famine of 1845 to 1852, caused by the potato blight Phytophthora infestans, killed approximately 1 million people and drove another million to emigrate. In the decades that followed, wave after wave of Irish left the island, fleeing poverty and colonial oppression, seeking survival and dignity in America, Canada, Australia, Britain, New Zealand. Today, the Republic of Ireland has a population of about 5 million. Northern Ireland adds another 1.9 million. But the Irish diaspora worldwide is estimated at 70 to 80 million people. The largest concentrations are in the United States, where over 30 million people claim Irish ancestry, followed by the United Kingdom, Canada, and Australia. Genetically, the Irish did not just populate an island. They seeded a significant fraction of the English-speaking world. What do those 80 million people carry in their DNA? What is the inheritance that connects a 5th-generation Irish-American in Boston back to the incest king of Newgrange, the dark-skinned farmer woman of Ballynahatty, the blue-eyed milk drinker of Rathlin Island? Let us break down the modern Irish genome, the autosomal ancestry, the total genetic inheritance from all ancestors, not just the direct paternal or maternal lines, tells the full story. Approximately 40 to 50% of modern Irish autosomal ancestry traces back to the Middle to Late Bronze Age steppe populations, the Beaker migration that transformed the island around 2500 BCE. 30 to 40% comes from Anatolian Neolithic farmers, the legacy of the Ballynahatty Woman and her kin, absorbed primarily through the maternal line during the Bronze Age transition. 10 to 15% comes from Western hunter-gatherers, the original pre-farming inhabitants of Europe, whose genetic contribution has survived as a minority component layered beneath everything else. Small additional contributions come from Iron Age Celtic groups, Vikings, Normans, and later English and Scottish settlers. The Y chromosome story is even more striking. Modern Irish males carry the R1b-M269 haplogroup, specifically the subclade R1b-L21, at frequencies of approximately 80 to 85%. That is one of the highest single lineage concentrations of any European population. R1b-L21 is the direct paternal descendant of the Bronze Age Beaker men. It is not native to Ireland. It arrived with the Bell-Beaker migration from continental Europe, and it swept through the island so thoroughly that it almost completely replaced the Neolithic Y chromosomes. The paternal lineage of the vast majority of Irish men today traces back in an unbroken line to those Bronze Age pastoralist warriors who rode out of the Pontic steppe 4,500 years ago. The mitochondrial DNA paints a different picture. Modern Irish mtDNA is predominantly haplogroup H, at around 40%, with additional contributions from haplogroups T, U, K, and J. These are deeply European maternal lineages, showing continuity from the Neolithic period through the Bronze Age transition and beyond. The Beaker migration was a male-dominated phenomenon. Bronze Age men arrived, established dominance, and reproduced with local Neolithic women. The maternal line survived. The paternal line was replaced. This is the signature of the most formative event in Irish genetic history. And what of the incest king? The man in the Newgrange chamber, the son of siblings, the dynastic god-king of Neolithic Ireland? His direct genetic legacy was probably extinguished. The Y chromosome of specimen NG10, whatever haplogroup it belonged to, did not survive the Beaker turnover. His people, the Neolithic elite who built the Great Passage tombs, were genetically overwhelmed. Their monuments endured. Newgrange still captures the solstice sun every December, more than 5,000 years after it was built. But the bloodline of the builders was swept away, replaced by newcomers whose descendants now walk the green hills of Ireland, unaware of the dynastic civilization that once ruled the island. But here is the thing about ancient DNA. It does not just reveal what was lost, it reveals what persists. If you are of Irish descent, if you carry that R1b-L21Y chromosome, or those H and U mitochondrial lineages, you carry the biological echo of every layer of this story. The Western hunter-gatherers who first set foot on the island after the retreat of the ice sheets. The Anatolian farmers who built the first fields and raised the first megaliths. The dynastic god-kings who constructed Newgrange and practiced ritual incest to preserve their sacred bloodlines. The Bronze Age pastoralists who swept in from the steppe, bringing blue eyes and milk drinking, and the patriarchal social structures that would define Irish society for millennia. The Iron Age Celts who gave the island its language and its mythology. The Vikings who built Dublin. The Normans who built the castles. The generations of ordinary Irish people, farmers, fishermen, poets, rebels, emigrants, who carried these genetic threads through famine and oppression and diaspora to every corner of the earth. All of it is still there. The Neolithic farmer, the steppe warrior, the Celtic storyteller, the Norse trader, the Norman knight, the famine emigrant. The DNA does not forget. It holds every migration, every conquest, every love story, every survival against the odds, in a 4-letter code written in the nuclei of your cells. In the laboratory at Trinity College Dublin, the ancient bone samples sit in sterile freezers, fragments of petrous bone and tooth roots, waiting for the next round of sequencing. Each one is a time capsule, a message from the deep past addressed to the present. The work of Cassidy and her colleagues is far from finished. There are more tombs to sample, more genomes to sequence, more stories waiting in the limestone chambers, and the bog-preserved remains scattered across the Irish landscape. That story is still there, waiting to be found. But now, for the first time, science has spoken. If you want to see the next reveal, subscribe. Thank you for watching. See you in the next one. Thanks for staying until the very end. Goodbye for now.